One of the most important things about any service panel inspection is bonding and grounding and the main bonding jumper. So what is the main bonding jumper? The main bonding jumper typically is the bond at the service panel that is between the grounded conductor, the neutral, and the case of the service panel. And this is where all the other grounding and bonding usually occurs or is tied together at this point. 25028 of the NEC tells us what material is supposed to be for the bonding jumper. So it's got to be copper, copper clad, or some other corrosion resistant material. The NEC goes on to tell us that it can be a strap, a screw, or it can be of the wire type. 25024 of the NEC goes on to talk about grounding of service supplied systems. 24B goes on to give us the requirements for the main bonding jumper, and it tells us it has to be unspliced, or it shall be used to connect the equipment grounding conductors and the service disconnect enclosure, so the case, to the grounded conductor within the enclosure for each service disconnect. So 24C talks about the grounded conductor, and it talks about the grounded conductor needs to be routed with all the ungrounded conductors to each service. And this is for services that are 1,000 volts or less in our grounded services. So that grounded conductor is required to be brought to the equipment whether or not line to neutral loads are being used. So as an example, a fire pump controller, oftentimes an electrician will say, it's 208, I don't need the grounded conductor. And if it's a grounded service being supplied by a service for the fire pump controller, which it typically is, that grounded conductor needs to be there so there's a fault path back to utility. Okay, so in a typical residential service, like I have up on this slide, it shows you a 7200 single phase transformer with a secondary, a 12240 secondary, center tapped and grounded. So we have a grounded service here. In a grounded service, as NEC indicates, we need to bond the grounded conductor to the case, and that's what you see in this picture here. So what happens if we have a system fault, a ground fault? How does our grounded system work with the utility system to clear the fault? Whether it's NM cable or Romex or EMT or metallic wiring methods. During normal operation, electricity is trying to complete a circuit. It's trying to find its path back to utility so it completes the circuit. And what happens in a fault condition, if it faults to a case, some normally non-current carrying metal of the system, something that's normally non-current carrying, if it faults to that, by providing that path back to utility, you can clear the fault easier. So by providing grounds in an NM system, or by the EMT ground in a metallic system, by properly grounding and bonding the service panel and also equipment and devices, you're creating a low resistance path that will cause a high voltage flow back to the grounded conductor and back to utility, which will open the breaker